Lesson 7, Applications of Surface Area and Volume. The goal of this lesson is to use the concepts of surface area and volume of any 3D objects to determine the cost to produce a specific item. And whenever the taxes are not included and you need to calculate the taxes in Manitoba, the PST is 5%. So the total taxes generally in Manitoba, if they ask, is 12%. So we look today at 3 questions or 3 examples where we'll have to use the surface area and volume of 3D objects to determine the cost. One is a box. Next is a sphere or a ball, or plastic to produce. And the third is a washer. You will also required to refer to your formula sheet unless you memorize all of your formulas, which is a fantastic idea. So we have formulas reference sheet, and then we're looking at the surface area and volume. Just a little bit of introduction. As with 2D areas, surface area and volume are concepts that are constantly used. So the concept of surface area and volume in the real world. Surface area is used in applications where you need to find an amount of material, so for example, wrapping paper, plastic, or paint, that will comprise the outer shell of being manufactured. And the example we will have here, we'll be asked to find the amount of paper to wrap this box. And for example, you're looking at some kind of gift you like to wrap for someone, then you need to know the amount of paper you need to wrap. So that's an application of surface area. For companies that are manufacturing certain things like, an example we'll be looking at like a beach ball, for example, we need to know how much plastic they'll need. So in this case, you'll need the surface area of the sphere. So their actual application, and just a reminder, volume then is when you need to determine the amount of material, or like water or air, to fill inside of a shape being manufactured. For example, you want to know how much air will fill in, you need to fill this ball. So you need to find the volume in this case. Now, the application that the example we'll be using today, and for many questions you'll be asked, you'll need to find the surface area or the volume or possibly both. So you may use a concept of surface area or volume or both. And there will be a cost, or there may be a cost. In this case, there is a cost. Ask you what's the cost for this question. And whenever you ask to find the cost, as I mentioned earlier, you need to add your taxes. In Manitoba, it's 12%. So let's get a first example. You have a large present you need to wrap in a fancy wrapping paper. It is a snowblower in a box with the measurements shown in the diagram below. So here's the diagram. You will need 10% extra wrapping paper to have enough to overlap and tape. You want to wrap the box in wrapping paper that costs $5.99 plus tax. So we need to add our taxes. So we need to calculate the taxes to how the total cost of the paper. But it tells us each roll costs 50, sorry, each roll covers 50 square feet. So you need to buy these paper in rolls, but each roll is 50 square feet. So to find the costs for the wrapping paper, they ask you here, calculate the cost of wrapping paper required to wrap the box. Now the cost for the wrapping paper will be the amount of rolls, the number of rolls you need, because it's giving you in rolls here. Number of rolls of wrapping paper you need times $5.99 plus your taxes. Okay. So basically that's the overall statement. So we can put that down, the cost of wrapping paper is equal to number of rolls of wrapping paper multiply the cost of one wrapping paper plus one roll of wrapping paper plus taxes. So number of roll of wrapping paper, the cost for one roll. We already know this, the cost for one roll, which is $5.99. Plus your taxes here in Manitoba is 12%. What we don't know now is number of rolls. So this question is asking now, how many rolls of wrapping paper do we need? Now, each roll covers 50 square feet. So to determine how many rolls of wrapping paper we need to find how much wrapping paper we need to cover this box. Once we know how much paper we need to cover this box, we divide it by the surface area of one roll to give us the number of rolls. So we can see that here now. So this is the only thing we need here. So number of rolls of wrapping paper is equal to surface area now they'll tell us you need 10% extra. Surface area of the box plus 10%. So surface area of the box. Now, number of rolls. So divide this whole thing now by 50 because each roll, right, area for one roll. So we can put the area of one roll. So then you need to find the surface area of the box and add 10% to it. Let's go ahead and find the surface area. So from our formula sheet, we know the surface area of any kind of rectangular solid, like a box, is 2 times the length plus 2 times the width, 2 times the width, 2 times the length times width plus 2 times the length times height plus 2 times the width times height. So let's record that. 2 times length times width plus 2 times length. Plus 2 times length times height plus 2 times width times height. Now we need to label. Are we going to label? So we have this, the width, length, and height. So this is our width, 4. Your length is 5, and your height is 4. So we can indicate that here. We can put that aside, remind us what it is. So we have our length is equal to 5. Our width is equal to 4. And our height is equal to 4. Now these are all in feet. Now substitute 5 for the length. So we have 2 times 5, 4 for the width, plus 2 times your length is 5, times your height is 4, plus 2 times the width is 4, times the height is 4. Two times 5 is 10, times 4 is 40 square feet. Plus 2 times 5 would be 40 also square feet. Plus 2 times 4, 8. 8 4 is 32 square feet. So total surface area of box is equal to 40, 80, and 32 gives me 112 square feet. Now, we've solved this issue, surface area of the box. So now we have the surface area of the box, the line across here. We need to find out the number of rolls of wrapping paper. But the total surface area of the box, the number of wrapping paper we need is plus 10% of it. We need to add 10% to, so we need total amount of paper equal to 112. Now we need to add 10%. The easiest way to do it is to multiply by 1.10 because I'm including a 10% in there, so it gives me a total of 123.20 square feet. So amount of wrapping paper I need is this amount here. Now, here now we've solved amount of wrapping paper. We need to find the number of rolls now. So this amount of rolls, so the amount of rolls of wrapping paper, so you need to divide by 50. Okay, number of rolls of wrapping paper is equal to total amount of paper divided by 50. So this is 123.20 square feet. 123 divided by 50 square feet. And get our wonderful calculator out here. Let's see how that work out to be. 123.2 divided by 50 gives me 2.464. Now we need to round up because we cannot buy part of our roll. We need to buy the whole roll, so we've rounded up. So number of rolls of wrapping paper, we need 5 rolls. Oh, sorry, 3 rolls, not 5. So wrapping rolls of wrapping paper. So now we're going to go back to our original formula. Number of rolls times $5.99 plus 12% tax. To make it easier to work, we will multiply by 1.12. So let's find the total cost. So final answer, the cost of wrapping paper. So here's the cost of the wrapping paper is equal to number of rolls, 3 rolls, multiplied by $5.99, multiplied by your taxes here. Remember, you're multiplying by 1.12 because this will give you the price for 3 rolls. This part here will give you the price for 3 rolls. And then you have to add the taxes to it. The taxes is 0.12, which is 12%. I'm changing 12% to a decimal, which is 0.12. The 1 refers to the price before tax. That's why you multiply by 1.12. Just a reminder, this could be done separately. You could calculate the taxes by multiplying 3 times 5.99 times 0.12. That'll give you the taxes separately. But then you have to add it to 3 times 5.99. It's more work, but it gives you the same result. Work all of this out. The answer becomes, let's put this guy out here in the calculator here. Clear, we have 3 times 5.99 times 1.12. Give me a cost of $20.12. Try it again, make sure we got the right answer here. So we have 3 multiplied by cost is $5.99, 5.99 times 1.12. So $20.13 we need to round up. $20.13. So our final answer, $20.13. Remember, let's refer to your taxes, price, and number of rows. Okay, let's go on to the second example. A company manufactures beach balls made of plastic and filled with air. The ball is a sphere with a diameter of 20 centimeters. So we're looking at, here's the ball, and it tells us the diameter of the ball from one end to the next is 20 centimeters. So we can calculate the radius would be 10. So we can say the radius is 10 centimeters. So it's a sphere. The question is how much plastic will be required to manufacture the beach ball? Now, what they're asking now is for the surface area of the sphere. So how much plastic is required to manufacture beach? Because it tells us here that the ball is filled with air. It's not a solid. If it was a solid, then we'll need to find the volume. But here, just the outer layer you need. We are looking now for the surface area. Surface area, and this is a sphere. So now we go to our formula sheet. Surface area of a sphere is 4 times pi times the radius squared. Okay, so we record that, 4 pi r squared. We know the radius is equal to 10 centimeters. We will substitute the radius 10 for the radius. So we have 4 times pi times 10 centimeters squared. So surface area, then what the plastic need? Now, let's do that out here. We get here 4 multiplied by pi multiplied by 10 squared gives me 1256.64 cubic centimeter, or sorry, centimeter square. 1256.64 centimeter square. Because we deal with area, we have to use a square. Next, they ask us how much air would be needed to fill the ball. Now we're looking at the amount of space within this ball. Therefore, we're looking at volume. So now we're going to look at the volume of the sphere, which is 4 over 3 pi r cubed. much air? We're asking for the volume. So volume of sphere is equal to 4/3 pi r cubed. We know radius is equal to 10 centimeters. So the amount of air then would be 4/3 pi 10 centimeter cube. So let's go about doing this. Now, your calculator may not have a power button like the one I have here. But if you do have one such as this calculator, then what you could do, you could put 10 to the power 3. So 10 is the power button here, to the power 3. Some calculators may have an x to the y button. You'll see, like x to the y. It means you'll, in this case for 10, the 10 will be, the x would be 10 and the y would be 3. So you'll have to look at your instruction for your calculator. And how we have that multiply that by pi. Now we have to multiply by 4 and divide by 3. So multiply by 4, enter, or divide by 3, gives me 4,188.79 cubic centimeters, which is 4188.79 amount of air to fill the ball. So the amount of air required to fill the ball would be this amount here. Just to recap, for some calculators, now if you, a calculator such as what I have here, you could have done all of this in one. You could have done this now. This is a fraction, you could have put it separately here. So open bracket, I'll show you how to do that with, which is 4 divided by 3. Whenever you have a fraction and you're using a calculator that has brackets, always use brackets, 4 divided by 3. This is a void because some calculator doesn't separate whenever you do 4 divided by 3. If you do 4 divided by 3 times pi, it should, but some calculators I know do not follow the order of operation. So to avoid any kind of mistakes, put a bracket around this. So I will do this like that. Then I'm going to multiply by pi. Then I'm going to multiply by, now if I don't have the power button, then I go 10 times 10 times 10. And that'll give you the same result. Or you want to do a shortcut again, you go 4 divided by 3, close bracket, times pi times 10 to the power 3. All result in the same answer. The next part, now if plastic costs $0.002 per centimeter square, how much plastic would it cost for one beach ball? So we've calculated the amount of plastic for one beach ball, right here. So the cost now is the total surface area for one ball divided by the cost per centimeter square. Because we're using centimeter square as a unit, we don't have to do any more conversion because they give us, the units are consistent. So the amount of the cost of plastic one beach ball is equal to surface area of one ball one beach ball multiply by the cost. Well, basically looking at multiply the cost per centimeter plus your taxes. Now the surface area of one beach ball, we found it here, is 1,256.64 centimeters square. The cost per 1 centimeter square is $0 here. Now, remember I said when you're adding taxes, you multiply by 1.12. So let's work that out. So the first part here. So we have 1256.64 times 0.002 give us $2.51. Now that's the cost to the price of, for the plastic of one ball, but you need to add your taxes. Now this is my taxes here. So 1.12. So $2.81. Now, if you had put your answer here in one decimal place, you'll have a different result here. It needs to be $2.80. It's slightly different. So try and put your final answer in two decimal places if you have more than two decimal places. So this is the cost of plastic. Cost plastic for one beach ball. The final part of this question asks you how much would it cost to produce 100,000 beach balls? So cost. Now here we have the cost for one beach ball. So cost of 100,000 beach ball would be the cost for one multiplied by 100,000. So we can say here cost of one multiplied by 100,000. Well, because we already included a tax here, we don't have to find any more taxes because if taxes are included here. So we can put here taxes included. So the cost of one beach ball is $2.81 multiplied by 100,000. Let's see what our answer is going to be. So multiply that by, now we put 2.81. Oh, let's clear that. Multiply by 100. 281,000. Final part to this question. The cost of one beach ball times 100,000 will give you the cost to produce 100,000 beach ball, which works out to be $281,000. Our third example, a hardware supply factory makes washers. And here's a picture of a typical washer, which is a small metal disc placed between the head of the bolt and the nuts. Whenever you are bolting anything into a wall or any kind of a machinery. So it's so this example of a washer. Now the washer is 1 millimeter thick. The diameter of the washer is 15 millimeters. The radius of the hole is 7 millimeters. So let's label it here. So we have the diameter from here to here. Tell us what the diameter is 15. So we have 15 mm. Our radius will be half of the diameter, which works out to be 7.5. But they tell us the radius of the hole is 7. All right, so now we have a hole here. So the radius, this is for the outer. Now we have another one here. So the inner hole, so we have 2. Tell us the radius of the hole. So if you look at the radius of the hole is 7 millimeters. So the diameter of the washer is 15 millimeters. the radius of a hole. So if you were to look at this as a, replace that. So we go from here to here, it's 15. Then we have the radius of the hole now, here to here, 7. Now, I think this question here, it meant that the diameter of the hole, not the radius, because that wouldn't give us any metal. So we changed this question here to diameter. So in your question, I think this question need to be changed to diameter. It's in your booklet as the radius. So we change it to diameter now. That will make more sense. So we'll remove this diagram here. As you can see, this question will give us no metal. So if we make this the radius here now, so let's do our diagram here. So we have our diameter here would be 15 millimeters. We have an inner, so the radius here is 7.5, as we got here. So the inner one, let's say we have an inner circle in here. So I'll just remove this inner diameter is 7 millimeters. So the radius here is 3.5. So the diameter is equal to 7. So the radius, 3.5, these are millimeters. They tell us the height now. Okay, so we have our, you need to find the volume, how much space. They tell us the height of this guy here is 1 millimeter. That's how thick it is. So we have our height now is equal to 1 millimeter. So those are the dimensions we have after making an editorial change here, or else we wouldn't have any we probably would have just a 1 millimeter of a washer, and that's very, very thin. Although that's possible, we'll change it because it's more realistic that we have this. Now, the question asks you determine amount of metal. Okay, so this will be the metal part here. Okay, there's a hole in the middle. So the amount of metal you'll have to do is like if you have to calculate the volume of the outer. Let's imagine this is all filled up. There's no hole there. Find the volume for the whole washer without a hole. Then find the volume of the hole. And what's left? To find the volume of the metal would be the volume of the outer part minus the volume of the hole. That will give you the volume of the metal you needed. So we need to find the amount of metal to produce one washer first, and then we multiply that by 1 million to find the amount of metal for 1 million washers. So let's start off first here. So we need to find the amount of metal for 1 million washers. So this overall, now we can say the amount of metal for 1 million washer That's what they're asking here. Is equal to the volume of one washer. Multiply by 1 million washer. Now, let's find the volume for one washer. So this is the overall picture here. We need to find the volume of one washer times 1 million, give us the amount of metal for 1 million washers. So volume of one washer So we need to find the amount of metal, right? So we're treating this as two volumes. One is the outer. Think of the washer without a hole. Then find the volume for the hole. And we'll subtract the volume of the hole from the volume of the outer part of the washer. So we're going to call the volume what we outer volume of outer washer minus the volume of the hole. Now the volume of the outer washer would be, now we need to find the formula now, right? Now go to a formula sheet and this gives you pi r squared times height. So the volume of it, now because it's a cylinder, so we establish that, pi r squared times height. So you can see here's a height, in this case for this washer is 1 millimeter. The radius, 7.5. That's for the outer washer. Let's imagine now you have a washer, let's without any hole in it. And in this case, we have 1 millimeter here, and entire cross here is 15, so it'd be 7.5. So R is 7.5, the height is 1. So move this here. So volume is pi r squared times the height minus pi r squared times the height. So this will give us pi. The radius is 7.5. And our height is 1. So that's your outer washer. And the volume of the hole, so minus, the volume of the hole would be, so we can do all of it here in 1. Which give us pi, the radius is 3.5. Okay, let's look at meter here. So I need to change this into volume of one washer. Just pi times the radius is 3.5 times the height is 1. Remember, the height is still 1 millimeter, mm. Because if there's a thickness, tell us it's thick 1 millimeter. So get a calculator out here. Let's do some calculation. See maybe here. So we have pi times 7.5 squared times 1 give us 176 0.71 millimeter cube minus we have second pi 3.5 squared times 1 gives 38.48 millimeter cube. With the result, we have 176.71 minus 38.48 gives me 138.23 cubic millimeter. So volume of one washer it's 123.23 138.23 cubic millimeter. Now the final part to this question. How much metal do you read? So this is the amount of metal. So we can see an amount of metal for one washer. So we have determined the amount of metal for one washer. The question is, how much metal do you need for 1 million washer? So the amount of metal for 1 million washer will be the amount of metal for one washer multiplied by 1 million. So metal required to produce 1 million washers is equal to 138.23 So you have 138.23 multiplied by 1 million. It worked out to be, oops, a dollar, cubic millimeter. It's 138.23. Oh, let's put this nicely. It's 138,230,000 cubic millimeter. So just to recap on this question here, you asked to find a washer. Let's make an editorial change in the question. The diameter of the hole is 7 millimeters. Now the radius. If the radius was 7 millimeters, then the diameter would be 14, and that would just give us 1 millimeter. That will be too easy of a calculation, I say. Although it's quite possible to have a washer 1 millimeter. It's unusual, but it's possible, highly likely. They ask you to determine, here giving you the dimension, determine the amount of metal to produce 1 million washers. So first thing we did, the amount of metal for 1 million washer is the volume of one washer times a million. So we need to find the volume of one washer. To find the volume of one washer, we look at this as two volumes. Outer, find the volume of the washer without a hole. That's the volume of the outer washer. This is no hole. So we can put here no hole. And here's the volume of the hole. So subtract the volume of the hole from the entire washer without a hole, and that will give us the amount of metal for one washer. Once we know the metal for one washer, then we multiply by 1 million to give us the amount of metal required for 1 million washers, which worked out to be 138,230,000 cubic millimeters. So to recap, today's lesson, our goal is to use our concepts of surface area and volume of any 3D object to determine the cost to produce a specific item. Recall our PST is 7% and GST is 75%. So it gives a total of 12% in terms of taxes. Just one reminder, whenever we're calculating taxes or increasing by 10%, etc., we can multiply that amount by, in this case, here was 10% increase and multiplied by a whole number. When we're calculating taxes, oops, so I'll straighten it here. When we're calculating taxes, we can multiply the price by 1.12, and that will give you the total price. It's a shorter way of doing it, but you can, the alternate way of doing it is to find the taxes separately and then add it to the price of the product. And now you may want to try some of these questions 1 to 4 in assignment 7 in your booklet.